because the way we're doing this is we're going to end up with this row in the database. Here's this database, and there's going to be 2 columns, and there's a bunch of rows, and then here's going to be CSEV 4 and Jen 3 and Stephen 6, right? So these are the counts, and so we're grabbing this variable out if it's CSEV that we're grabbing, and that's going to come into here, right? That's going to show up in here, and that row is actually, it turns out that the row is a list, but we're only getting one thing. And what we really are doing is if we search through and we got through and there was nothing, then row is none means that there was no, and we're seeing like Chen's for the first time, and we have to insert it. So if row is none, we're going to run an insert statement, insert into counts, email count. Now we've got to set it to 1 because it's the first time we've seen it. So values, and then again the question mark. The question mark basically says, hey, I'm going to have a value in this tuple, and there's an ordering to the tuple, and so there's only one question here, one question mark placeholder here, and then 1 is the initial count. So email question mark count 1, away we go. And so then we have a tuple that gives to this execute statement, just like in that execute statement, the corresponding sort of strings or integers that are to be replaced by each of the questions. So when this runs, there's going to be a new record, and there's going to be a 1 that's put in there into that new record. If, on the other hand, we pull back a row that exists, we're going to get this 4 number. And you might think we want to take this 4 number and add it, but in databases it's always better to do an update because there might be multiple applications that are talking to this database at the same time. So no matter what update does is in a single atomic operation, it turns whatever this number is into 1 higher, and we don't have to worry about other pieces of code potentially modifying it. Now in this case we don't have to worry about that because we're the only piece of code, but using update to increment something is way better than reading the value and then doing an update to adding 1 inside of Python and then updating the new value, that's 2 SQL statements, but it's also not atomic, okay? So if the row is none, if the row exists, we just know that it exists, and we just want to add 1 to the number. We do have the number sitting here in the row variable, but we don't need it. And so we're going to say update counts, set count equals count plus 1, column name, where email equals, and then another placeholder, and then another tuple for the question mark, okay? And so that's what this little bit of code does. That is kind of the read it, parse it, check to see if it's there. If it's not, insert it. If it is, update it. And so then we see this con commit. And this con commit, basically the way it works is that the database is efficiently keeping some of the information in memory, and at some point it has to write all that stuff out to disk. So you can choose at times where you put this commit. Right now we're going to commit every time through this loop, but you might commit every 10th time through the loop because the commit will take some time because it forces everything to be written to disk, and these can run really fast, and the commit is the slowest part here. So sometimes we do things like commit every 10th record or every 100th record. If it's an online system, which is not what this is, you have to commit at the end of every sort of screen paint. But for this kind of a system, because we're putting so much in, this is kind of a bulk insert, we might come up with a thing where we, every 10th time we do a commit. But ultimately what this will do when this is running is it will build up slowly but surely, adding new records, and then 1, 1, and then it'll be a 2 and a 3 and all these things, and add another one, that'll be 1. It'll do this thing, right? And then at the end of the day, that is what's going to be in the database. Now, so let's take a look what's in the database, and now we can actually read the database. And so in the database, we're going to run a select, and we're going to select the email and the count from counts, order by count, descending. So look at that, isn't that cool? We're getting in the top 10 because databases are good at sorting, and they're good at all these other things. So we're going to then execute this, and then we're going to ask for the rows 1 at a time, and the rows are going to be a tuple, and row sub 0 will be email, and row sub 1 will be count. So we run all this stuff, and then we close the connection, and away we go. Okay? So let's go ahead and run this. Let's go ahead and run all this stuff. Python 3 emaildb.py. It asks for a file name, mbox short. Well, I can hit enter, right? Mbox short. And that's it. And it looks just like that, and it counts it, and away we go. Now the difference is, at this point, we have a file, emaildb.sqlite. And we can run the SQLite browser. And we can then open this database. And we can see what's in there. So here we go. It has made an SQLite database. We have a table of counts. And then we can take a look at the data. And there we go. We've got the data and we can do this. And so let me close this. It's important at times when you don't want necessarily to have, well, let's see if we can cause it to lock up. Let me run this again, and it's going to drop this table. So I'm going to run the code again. But this time I am going to do the full one, mbox.txt. Now we'll see what happens here. But it ran, and now so what we have to do then to see this date is from the previous run, but if we want the most recent one, we hit refresh, and then away we go, and so we can see this stuff. And so this is just a real simple start to see how you can connect some of the stuff that we've been doing, but store the data in a database. But the nice thing about the database is that it can store this stuff from run to run, even though in this case we're dropping the table every time. In later things, we will see how we can store data from run to give ourselves more restartable processes. Cheers. We're going to do some code walkthrough, and if you want to follow through with the code, you can download the sample code from Python for Everybody. And so the code that we're going to play with is the Twitter Spider code that is both talking to the Twitter API and talking to the database. And so what we're going to be doing is we're going to run code that's going to hit the Twitter API much like we did in a previous chapter, and we're going to retrieve the data, but we're going to remember the data so we don't have to retrieve it again. Okay, and so we're going to keep track of people's friends, and what we're doing here is sort of illicitly pulling down, slowly but surely, based subject to our rate limit, we're pulling down who our friends are. And so let's take a look. We're going to use URL-lib and URL-lib error, Twitter URL, which was code that augments my URL to do all the OAuth calculation. We're going to get JSON data back. We're going to make a database, and we have to import SQL because of the way Python doesn't trust any certificates, no matter how good they are. So this is our URL to talk to the Twitter API. We're going to make a database, and again, the way SQLite works is if this spider.sqlite doesn't exist, it creates it. And we get ourselves a cursor, and we're going to do a create table. This, if not, exists. Some SQLs, but SQLite 3 does this. Create table if it doesn't exist. We want to start this over and over. Unlike the tracks example, I want to start this over and over and not lose data. And this is a spidering process, and we'll see a lot of these where we want a restartable process where we use a database. So if we're starting with nothing and there's no file, a Spider SQLite, it creates this table, and it's the name of the person, whether we retrieved it or not, and how many friends this person has that we know of in our database. Now this little bit is to deal with the SSL certificate errors. The certificates are totally fine, but Python doesn't trust any certificates by default, which is frustrating, but whatever. So here we're going to have a loop. We're going to ask for a Twitter account. We have to type quit to quit. If we hit enter in this case, we're going to actually read from the database an unretrieved Twitter person and then grab all that person's friends. Okay, and so then we're going to do a fetch one, get one, and that's going to get the name of the first person, the sub-zero. If we had more things than name here, sub-zero is the first of those. Fetch one means get one row from the database, and sub-zero means the first column of that first row. And if this fails, then we retrieved all the Twitter accounts. And so, you know, we're going to augment this Twitter URL using this makes, you can look at the twurl.py code. This basically requires the hidden.py file, which has your keys and secrets in it. You got to get hidden.py